This is a screencast that will calculate the kinetic energy and net work done. A 1,000 kilogram car speeds up from 2 meters per second to 5 meters per second. Find its initial kinetic energy, final kinetic energy, change in kinetic energy, and net work done on the car. First thing we want to find is the initial kinetic energy. We'll call that KE sub 1. We know that kinetic energy is 1/2 mv squared. This is the initial velocity of the car, so we'll plug in a sub 1, v sub 1. Now plugging in the numbers, we have 1/2 times the mass of the car, which is 1,000 kilograms, times the square of the speed of the car, where the speed was 2 meters per second. When you calculate this, don't forget to square the 2. Sometimes people forget to do that. When we do the calculation, we get 2,000 and the units, kilogram meter squared per second squared, is another name for a joule. We also want to find the final kinetic energy of the car. We'll call that KE sub 2. And again, it's 1/2 mv squared. This time the velocity is the final velocity, we'll call v sub 2. So plugging in the numbers, we have 1/2 times the mass of the car, which is 1,000 kilograms, times the square of the final speed of the car. The final speed was 5 meters per second. When you work this out, you get 12,500 joules. Now we want to find the change in kinetic energy of the car. Change in something, we use the notation delta. So delta KE will indicate the change in kinetic energy. That delta notation always indicates the final value minus the initial value, so be sure you subtract things in the correct order. That would be KE2 minus KE1. So with our numbers, that's 12,500 joules minus 2,000 joules. And that gives us 10,500 joules. We also want to find the net work done on the car, and the relationship that is important there is that the net work done equals the car's change in kinetic energy. This relationship is important to know because we couldn't find the net work done on the car from the formula work is force times distance. We would have to find it this way. And that again is 10,500 joules.